Okay, so as I mentioned to you guys last week, we are starting your materials this week. So we're starting with your textiles and fabrics. Some of this may be review from your textiles course that you took either freshman or sophomore year, but a lot of it will be new information specifically geared towards specification in an interior design setting. So we're going to start with the basics and then get more complex as we go along over this lecture and then the one that I will give you when I come back next week. So the objectives over this lecture as well as next week is to specify how yarn, weave, and finish processes define the characteristics of a textile. That is probably what is going to be more of a review from your textiles course, as well as understanding how the chemistry of the fiber affects performances. Now there's so many details when it comes to the chemistry of the fiber, so this is something that I'm sure you talked about in textiles, but you probably do not remember all the details of, so something that you will essentially be relearning. And then know when to consider or know what to consider when selecting and specifying a textile for specific use. All right, so a few basic and fun facts. Weaving is one of the oldest surviving crafts dating back to Neolithic times 12,000 years ago. The first loom, as you can imagine, they only had natural elements to work with, was a tree. The first woven textiles were natural, made out of natural fibers, so wool, and then after that was silk. And then mechanization of the spinning and weaving process evolved in the 1700s out of necessity. So how is a fabric made? It all starts with the fiber. The actual textbook definition of a fiber is a planar structure pliable enough to be made into 2 or 3-dimensional products that require some shaping and flexibility. So they're formed by most typically weaving and knitting. So here is when we start to get into the details. These tables, this one and the next slide, are information that you guys need to be studying and memorizing. And so when we talk about the chemistry of fibers and how those different properties will affect how you might use those fibers. So first of all, in fibers, we have natural fibers or man-made fibers. In the natural fibers, we have either protein or cellulosic fibers. Protein fibers are animal-based fibers, so they come from the 2 different types are silk and wool. Silk comes from silkworms and wool comes from sheep. And then the cellulosic fibers are plant-based, so they come from some type of plant. These I'm not going to go over every single thing in detail, but I'm going to call out some important information that you guys need to know. In general, silk and wool, they have a lot of opposite characteristics. Silk is a long filament fiber, where wool is a short staple fiber. So filament fiber is a longer fiber, where staple fiber is a shorter fiber. Typically, filament fibers are going to be much softer and smoother, and they have good tensile strength. So you see under silk that it has good tensile strength. Where wool or a staple fiber is something that's typically going to be springier and it might feel cozier because it holds in the heat a little bit better, but at the same time it typically is a little itchy. So you'll have to study all the different properties of all these different fibers, but some common uses that you'll see of silk is really light upholstery, and then sometimes drapery, high-end drapery, but whenever you're using it in a drapery, you have to make sure that it's lined because silk by itself will be degraded by UV rays. Often you'll see silk in blends. For wool, very common in carpet, very common in upholstery and in drapery as well. It's a very durable fiber. So carpet and rugs, things like that, you'll see it in often, but it's typically a more expensive item. Like I said, the cellulosic fibers, those are deriving from plants. So the main ones that we're focusing on, there are more, are cotton, linen, jute, hemp, and bamboo. Jute and hemp have a lot of similar properties. Typically, it's more of a novelty fiber. It is pretty coarse and rough, but pretty good for withstanding stains and things like that. You'll see it often used in rugs in residential and commercial settings. Cotton Very common for multi-purpose blends, so used in blends for upholstery, used in blends for drapery. It is soft and it drapes well, but it will elongate. So that's why it's typically used in a blend. And then it's also difficult to keep clean without treatments or use in a blend. So when you blend it with another fiber, it's typically to use the benefits of the 2 or 3 fibers together to make it a more durable product. And then linen, it's common in upholstery, but it's something that wrinkles extremely easily, so much more of a casual setting. Drapery, it also will elongate. It'll when it's humid out, it'll elongate, and then it can also shrink when it dries back up. So most often, if you're using it in drapery, it's going to be in a blend. Typically, linen is dry clean only, so it's nothing that's going to it's never going to be used in a setting that needs a lot or that'll have a lot of people coming through it. Now onto the man-made fibers. In man-made fibers, we have cellulosic fibers or non-cellulosic. So cellulosic means that it comes from a plant but has been altered chemically and mechanically. And then non-cellulosic means it's totally man-made, not deriving from any type of plant or natural material. So in cellulosic, we have rayon, acetate, lyocell, PLA, and bamboo. Rayon and acetate are probably the two that you will encounter the most in design settings. Rayon you'll see a lot often used as artificial silk. It drapes extremely well. It will have a similar hand and an appearance to a silk, but it is man-made and it will not be affected by UV rays the same way an actual silk is. Typically, it's not as expensive, easier. So if you want the natural, expensive, luxurious version, you do a real silk, and then if you want the less expensive, typically you would do a rayon. Acetate is one, like I said, you'll typically see them mixed. Used in multi-purpose and light upholstery. Very soft and drapable. It has a variety of lusters possible, so it's good for a large majority of settings or a large variety of settings. Lyocell is also something that you could use to simulate a silk or a leather, so there's a lot of different things that they can do with it. The great thing about lyocell is that it's biodegradable. It's used in a lot of multi-purpose fabrics. PLA stands for polylactic acid fiber. This is one that you probably won't encounter quite as much, but it has a lot of good properties. So good wicking, low absorption. It's a relatively light fiber. It has low smoke and flame spread ratings. But like I said, you won't see a ton of it. Another one that you'll see combined often in blends for multi-purpose fabrics. And then bamboo is a nice one. What's really great about bamboo is it's antibacterial. Even though bamboo is a wood product and it's not soft at all, it's a very hard product. When it has been mechanically and chemically altered, it has a very soft and drapable hand. You'll see it mostly used in novelty fabrics, but maybe you'll see it mixed into some upholstered settings. In the non-cellulosic, these are some of the ones that you'll run into more often. So polyester and nylon are two of the most popular fibers that you'll probably see. You will see them a lot in carpet, upholstery, drapery. There's a lot of different things that you can use polyester and nylon in. Carpet is probably one of the biggest. Carpet and rugs is probably one of the biggest areas that you will see them. So polyester resists wrinkling fairly well, resists shrinkage, resists mildew. It's pretty good in flame settings. It has a crisp hand, but the one thing about polyester is it does spring back, but not quite as well as a nylon. So think about nylon clothing that you might have. It spreads out and then it shrinks back up pretty well. So the same properties that you see in your nylon clothing, you'll see when it's used in interior design setting as well. So when you're comparing polyester and nylon carpets, nylon in general, it's not quite as soft as a polyester. So often when you're feeling your different products, and you're comparing a nylon and a polyester rug, for example, you might be, or your clients might be wanting the polyester because in general it does feel softer, it feels a little bit more plush, but in the long run the nylon is typically going to be something that's going to be better for continuous wear and tear, especially in commercial settings, so something that gets a lot of use. Acrylic is nice because it can resemble a cotton or a wool, so you'll see it used often like you would see a carpet or a cotton or a wool used, a lot of carpeting, upholstery. You will see polyester and nylon, like I said, are probably the two most popular out of these non-cellulosic, but you will see acrylic a lot as well. Generally pretty easy to dye and work with. It resists wrinkling well, and also resists soiling and damage from UV rays. Polypropylene, one that you probably won't use a ton, but you'll see often, or you'll see sometimes. Once again, carpet, upholstery, often used in blends. And then glass, typically you only see that when you're working with window coverings. So the great thing about glass is that it's flame resistant, which is one of the reasons that you'll often use it for window coverings. One thing that I quickly want to go back over is make sure you're noting when I have it noted that blends may pill or the fibers might pill, because pilling is really important, especially when you're using it in an upholstery setting, because when people are consistently sitting on a product and using it, the pilling, even though it might not be degrading the product, a lot of people will think that the product, whatever they're using, is degrading because of the pilling. So they'll be more likely to get rid of it or think that they need to replace it, even though it probably is still structurally sound. The criteria that we should be using when we're evaluating a material is its resistance to the following, especially in commercial interiors. So I've said multiple times, and I'll say it again, and I'll probably say it all next semester as well. Commercial interiors are much more strict because you have many more people using the spaces typically. And we typically want to select our materials based on the kind of worst case setting. So what's going to happen in the likelihood of an emergency. So first you want to evaluate for flame. We talked about some of the testing that is done for flame, but common sense, fibers, textiles should not support a flame. And then smoke generation, even if a textile does not support a flame, so it does not light on fire, does not flame up, smoke can still generate and obscure people's vision. So as they're trying to exit, that makes it extremely dangerous. But it can also release toxic gases and chemicals as well. As far as abrasion, fabric that will abrade from wear through friction will obviously limit the life. So if your space is going to get a lot of use, a lot of people coming through it, the abrasion is very important, not popular. Any fabric that stains in a commercial setting needs to be cleanable. And even if it is cleanable, you have to make sure that you're educating your client, because a stain or a soil, often there'll be the materials or the whatever it may be, the sofa, the chair, the rug will be thrown away because people will think it can't be serviceable even though it might be. Static is important in anywhere that there's sensitive equipment. So think things like hospital monitors. Those types of machines can be disrupted by any different type of electrical charge. So moving drapery, for example, in a hospital room could transfer electrons and create a static cling, which could interrupt the machinery that's running. Crushing is when a fiber can flatten out where weight is being applied, where you're walking, where you're sitting, and appear worn and not usable anymore or look like it needs to be replaced, even though it could still be in good shape. Moisture, you want to think about absorbent fibers. They may change with humidity. Like I said, cotton is one that could elongate from humidity or water, whatever it may be. So those types of fibers will shrink and grow. If a fiber has a high moisture retention, that typically though it means that the fiber will be more comfortable. It's going to be softer. What type of chemical makeup it has, that's going to definitely affect the cleanability of the fiber. The tear and burst strength. If fibers break, they're likely to pill or tear. They need to be able to endure sharp objects, people sitting in different manners. Think about in waiting rooms, people might sit with their feet crossed on a chair with their foot under them. They need to withstand all those different types of pressure that will be put on the upholstery. And then seam slippage. This is probably most commonly seen in upholstered settings, so like upholstered seat. It's when the fabric will split at the seams, so it is stressed seams. You want to make sure that your upholstered fabric, whatever fibers that you're using, are going to resist that as best as possible. This next slide is a table taken straight from your textbook, Characteristics of Fiber Chemistry. This is a great reference resource for you guys to use when you're working on specifying or when you're looking for what different fibers will be appropriate for what different settings. Sorry, my dog is whining in the background. So what this table does is lists out the fibers we just discussed, as well as many different characteristics as well. So flame resistance, moisture regain, abrasion resistance, so on and so forth. So a way that you might use this table, and we'll actually practice using it in your in-class assignment, is say I give you an example. What would be a fiber that you are looking for a commercial carpeting or to use in a commercial carpet? So when you're looking for commercial carpeting, you really flame resistance is extremely important. You want it to be very abrasion resistant, as well as you want it to be elastic. So it's going to have high durability as well as recover well from the continuous people walking over it. And you want it to be resilient as well. So something that'll, spring back. So if you look at the list, wool has high flame resistance, high abrasion resistance, high elasticity, and high resiliency. So wool is one example of a fiber that would be great for a commercial carpeting. So this is a table that you guys really want to be studying. You want to know the properties of fibers as best as you can so that when you are picking out fabrics, textiles, for whatever setting, you can easily acknowledge and address if that fiber, that chemistry of that fabric based on the fibers is going to be appropriate for whatever use you're looking for. So like I said, it all starts with the fiber, and the fiber is the basic component of an overall textile. But there are other functional outcomes as well that'll affect the final textile product. So we went over what the fibers are, what they're made out of, and the various fiber characteristics, which you will have to study more in depth. But things like, are the fibers slippery? Are they stiff? Are they springy? All these different fibers that have their different characteristics will affect the final outcome of a textile differently. The different fiber characteristics as far as length. Is it a filament fiber or is it a staple fiber? The filament fibers, like I said, are longer, so generally they feel smoother. Whereas the short fibers might have ends that might poke out of a product, which might be a little bit itchier, but create a warmer, cozier product. What is the kink of a fiber like? So does the fiber have some sort of curl or kink to it that could potentially elongate when it's put into a textile, making that material stretch out? And then we will get into yarn characteristics, density of a weave, weave construction, as well as processes throughout this full lecture. But yarn characteristics that go into the component or that affect a textile. What is the thickness of a yarn? So a thicker yarn is going to put more fiber into the construction of a textile. So even if some of that fiber wears away over time, there'll still be fiber holding that structure together, making it more plump. Is that a high twist yarn or a low twist yarn? A high twist yarn is something that's going to create more body of a textile. So it's going to make it a little bit stronger. The density of a weave. So how tightly packed are the yarns and the fibers in a textile. So the firmer and more stable, the denser the product, the more firm or stable a fabric will be. As far as weave construction, we'll go over the different types of weaves, but some weaves are more durable and stable than others, and then the various processes that go into creating a textile as well. So treatments and chemicals that are applied to fibers as well as overall fabric, those can alter the characteristics and the performance of a fabric. So this is the first of your 2 in-class assignments. This is geared towards applying fibers in an appropriate setting, so it's called Selecting Right Fibers exercise. This was geared towards you doing it in class, so I said originally to get into pairs and then provide 1 submission per pair. So you can do it with a partner if you want, or if you're at home working alone, you can submit it by yourself. That's fine. Just make sure that if you are working with someone, both of the names are on the PDF that gets uploaded to D2L. So this should be uploaded by the start of class, Monday, September 24th. There's 10 questions that you will give me a fiber answer on. So some questions might have multiple fibers that could be the appropriate choice. You only need to supply 1. You will be using the table, the characteristics of fiber chemistry that I took straight from the book, as well as the man-made and natural fiber tables that I have in this lecture as well. So I'm going to read through the 10 questions quickly. Obviously, you guys can pause it and answer them at your leisure. Number 1, what is an appropriate natural fiber to use for a rug? Number 2, what is an appropriate synthetic fiber to use for a drapery? Number 3, an example of a flame-resistant natural fiber would be blank. Number 4, a great natural fiber for drapery would be blank because it has a high UV resistance. 5, blank would be a bad man-made fiber for carpeting because it will not spring back well when someone steps on it. 6, if your client is looking for a coarse fiber for a rustic-looking wall covering in a residential setting, what would be an appropriate choice? Number 6, if you are looking for a synthetic fiber carpeting that will resemble a natural fiber, what would be an appropriate choice? Number 8, an example of an easy-to-maintain fiber to use in a commercial upholstery would be blank. Think about cleaning, abrasion, because it will get a lot of use, and then fire resistance, flame resistance. Number 9, if you are looking for a wrinkle-resistant natural fiber for upholstery, blank would not be a good choice. And then number 10, name a natural fiber and a man-made fiber that you might blend together to create a residential upholstery fabric. So like I said, answer those 10 questions, upload them to D2L in a PDF form by the start of class, Monday the 24th. Your second in-class assignment is to practice writing a specification. So a specification in a spreadsheet format is probably the most common type of spec you will write in this class as well as the rest of your time at MSU. It's also very commonly used in the field for small as well as large products because it's a really easy way to organize things, and it's a way to see the information on the product very quickly without going through that large CSI spec that we were practicing writing earlier. So what I want you guys to do is you can stop in the workroom, or you can take a fabric that you might have in your library at home if you have some extra fabrics laying around from old projects. It doesn't matter what fabric, it's just practicing writing a specification. So get a fabric, and then I want you guys to determine an appropriate use for the fabric and then create a specification. So once you have your fabric, you will create a spreadsheet that looks like this. So you will have 1, 2, 3, 4, 5, 6, 7 different headers, and you will follow the same description. So first you'll have the key, which we'll go over in a second. Then you'll list your product, the manufacturer, style, name, and number, description, amount, and notes. So your second step after getting your fabric is to set up this little spreadsheet. And this is a little spreadsheet that you will continue to use. So the key, first of all, is something that you'll just make up. That'll be when you guys actually have a product and you have a materials board, and it'll just be the label, so that when you're looking at your materials board, you know that this is the line item that corresponds with that material. So you guys are probably used to noting things like CH1 for the image of your chair. So the key for the purpose of this assignment is totally made up. But when you are using it for an actual product, this will be the key that marks that this is the specification, this is the material for this sample on your material board. So filling out the remainder of your spreadsheet. Product, what is it? What is it that you're specifying? That's what goes into your product category. Manufacturer, who made it? This should be on your fabric sample, as well as style, name, and number. Some fabrics will only have a name, some will only have a number, but most often they will have both. Description. This is the description of your product. What color is it? What it's made of, so like what type of fibers are in it. Any of those types of details will go into the description portion of your specification spreadsheet. Amount is the quantity needed to order, so you can estimate properly. This, for the purpose of this assignment, just going to be a quantity that you make up. And then in notes, you'll have any other pertinent information. So any of the codes or tests that it has passed, any sustainability notes, this will all be on the fabric sample that you have, or should be on the fabric sample that you have. So this will be the very common specification spreadsheet that you will be using for the remainder of this class, next semester, and next year as well. Like I said, it's a much quicker version to see what type of product that you're working with versus the CSI specification, and get the really pertinent information that you need for ordering of the product. So you'll create this spreadsheet, like I said, fill in the blanks, but then it's something that you're going to want to save on your computer, because you'll go back and add to this and edit this for many, many projects to come. So when you filled this out, when you filled this out, I want you guys to also PDF this and upload this to D2L. Any questions that you have, I'm not looking for it to be perfect, because at this point I'm really just wanting you guys to practice writing in the most common type of specification that we will be using. But I want to make sure that you guys are trying it out, and then I can answer any questions that you may have specifically on this in class next week. So next we're getting into yarn manufacturing. So we take the fibers and we create yarns. This is something that will probably be reviewed for you guys from textiles. It's a lot of definitions that you guys need to memorize and just know how they are applied. So first we have spun yarns. Spun yarns have plies. So a ply is an individual strand of yarn. And then they have plied yarns. So a yarn formed by twisting two or more single strands. So if you look at that image, figure A is going to be a ply, where B and C are plied yarns, because you have in B, you have two different yarns, a two-ply yarn, and then in figure C, you actually have four plies that are being put into a yarn, which they're referring to as a cord yarn. The next definitions you guys need to be familiar with are woolen versus worsted yarns. So woolen yarns are fuzzy, loosey twisted yarns spun from short wool fibers. And remember, wool fibers in general are short. They're the staple fibers, but they can come in a few different lengths, but they're all generally shorter fibers. And then worsted is smooth, compact yarn spun from carded and combed long wool fibers. So they're going to be softer, smoother, where the woolen are going to be fuzzier. Spinneret, this is a metal disc with numerous holes through which a chemical solution is extruded to produce synthetic fibers, so only used for man-made fibers. Next, we have a few different novelty yarns. So novelty yarns, there are boucle, slub, or chenille, or those are the only three that you need to be familiar with. A boucle, as you can see, it's that yellow yarn image, It's a multi-ply yarn that retains a loop during construction. A slub yarn is a lump or knot in a yarn that is sometimes a defect and sometimes purposely spun to produce a textured surface in cloth. So you'll see that a lot in clothes that you might wear. And then the third is a chenille, so a fuzzy caterpillar-like yarn of either cotton or man-made fibers produced by looping short, cut fibers at right angles to the core of a thread or a fabric woven with chenille yarn in the weft, producing a cut pile surface. So those are the three types of novelty yarns that you should be able to recognize by looking at them. So how do these various yarns work together to create a fabric? There's two different types of yarns in a fabric called warp and weft. First, we'll go over the warp. Warp are the vertical running pieces of yarn in a fabric. So the lengthwise yarns in a fabric, they'll run vertically through the loom and parallel to the ends of a fabric. The ends of a fabric, technical term, is called the selvage. When you have a solid warped yarn, that means all of the warp yarns, so all of the lengthwise yarns in a fabric are the same type and the same color, so it's going to be very consistent. When you have an end-to-end warp, that means you have two different warp yarn types, and the yarn types or colors, whatever differs between the two, alternate across the beam. And then when you have a tapestry warp, that's when you have 4 or 5, 6 different warp colors that are in a rotation across the beam, and they create more of an intricate pattern, which we'll look at a few examples of. The other yarns are the filling yarns. So these are the yarns that run horizontally across the beam. So they're also referred to as weft or picks. They will interlace the warp yarns at 90-degree angles. So a solid fill is like a solid warp. That means all of the fill yarns are the same type and color. And then pick and pick means that you have two different fill yarn types and or colors alternating in the filling, so the horizontal running yarns. When an end count is referenced, that's the number of warp yarns per inch in the warp, which is expressed in ends per inch, but you'll typically see it shortened as EPI. The pick count is the number of fill yarns per inch in a filling, so expressed as picks per inch or PPI. So the higher the end count, the higher the pick count. The denser a fabric, the stronger a fabric is going to be. A balanced construction is when you have a fabric with an equal number of ends per inch and picks per inch. And then the count or the density, the number of ends and picks per inch of a weave. So like I said, the higher the count, the more durable and also the finer the weave will be. Getting into weaving, so weaves are created by warp yarns that are interlaced with filling yarns at right angles. There's two overall umbrellas of weave types. There's basic weaves and fancy weaves. So basic weaves are going to be the same simple interlacing pattern repeated throughout a fabric. The examples of those are plain, twill, or satin. Plain is going to be the simplest and most widely used weave. And then the fancy weaves are created by variations on the three basic weaves. So the plain, the twill, and the satin create the fancy weaves in which have textures or patterns on a fabric. A few definitions that you need to be familiar with. A loom is the machine that produces woven textiles by interlacing the warp and filling yarns. A dobby is a mechanical loom attachment that can regulate as many as 40 harnesses to produce small geometric patterns in plain weaves. And then a jacquard is a loom attachment that originally used a punch card system to raise and lower needles, versus now they're using computer-controlled mechanisms, but they create much more complex patterns and figures. Now onto the different weave types. So first we're going to go over the basic weaves, the plain weave, which is the simplest of all of the weaves. So in a plain weave, each warp yarn passes alternately over one and then under one filling yarn for the whole length of the fabric, like you can see in the image on the screen. A plain weave has the maximum number of interlacings, um, which makes it pretty good for snag resistance and then a low tearing strength. Negatives with a basic weave, the plain weave, is that it's going to be not as wrinkle resistant, and then it has a really uninteresting surface. That can also be a positive sometimes because that makes it really good for printing and finishing. Another positive of the plain weave is that it's going to be the least expensive of all the weaves. This is going to be the most popular weave type that you see. Next is the basket weave. So this is when you have groups of 2 or more yarns carried over as a warp or a filling yarn. In the 2 images, the image on top is a full basket weave, and it's a 2x2 because you have 2 warps and 2 fillings. And then the lower image is a half basket because you only have 2 with a vertical, or because you have 2 vertical and 1 horizontal, and that's referred to as a 2x1. What's nice about basic weaves is that they are reversible unless you print or finish on one side, so it should look the same on the front and the back. Positives of basket weaves is that they're very flexible and wrinkle resistant, more so than a plain weave. It is also pretty durable, but it can snag because of those interlacings, the 2 or more yarns being interlaced, and then it's more likely to shrink when it's washed. Next is the satin weave, which you can see in the image on the right. It has no adjacent interlacings, which is pretty clear in the image, but that makes it really smooth and lustrous, which is a nice positive of the satin weaves. They do have minimal interlacings. It has very high wrinkle resistance, drapeability, and pliability, so it's a pretty durable fabric, but it also makes it pretty expensive. So that's one of the biggest negatives of a satin weave. And then it's impermeable to air due to the very high yarn counts. So it's a pretty durable fabric, but it is one that's going to be more expensive. And then twill weaves. This is something you'll commonly see, a twill weave you see in your jeans. But it's very recognizable because of that diagonal pattern. So it has an uneven but interesting surface due to the diagonal line, so it's very easily recognized. Soils are less visible than a smooth surface because of that interesting and uneven surface. It has better wrinkle resistance than a plain weave, and it has medium luster. It's going to be more expensive than a plain weave, but less expensive than a satin, so somewhere in the middle, and it has pretty good durability, so good snag resistance as well as medium tearing strength. And then the herringbone weave is a type of twill weave which creates a zigzag pattern. So that's how it's most recognizable, but the same characteristics of a twill weave. Into the fancy weaves, there's 3 different types we're going to go over. A tapestry, which is a multicolor warp that creates complex and colorful patterns and figures. You can see that image on the upper right. This and a damask are woven on the jacquard looms. So then the damask is most commonly only 1 or 2 colors, but can sometimes be up to 4, and is very recognizable by the pattern that you see in the bottom right. And then the last type of weave that we will go over is the cut pile fancy weave, so a cut pile fabric. It's cloth with a 3D surface produced by double weaving or looping, that should say looping, not looking, an additional warp or filling thread into the fabric. So this is how you create velvets or corduroys. That is where we will stop today. I do have examples that I will show you guys, fabric examples that I will show you guys next week of many of these different types of weaves, so you can see them in person and apply them a little bit better. And then next week we will get started in knits. So have a good weekend.